Hello, I am Kyle Deshaw, and today I'm going to be explaining Webwork homework assignment number 12, question number 8. Now, what's special about this problem is it's a two-parter. I thought this problem would be helpful considering it involves solving double integrals and dividing integrals, which you need to do in order to find the average. So let's start with our basic integral formula right here. Which that'll be, we'll start with the x max and the x min and the y max and the y min, f of x and y, which is the function of x and y, which we'll also fill in later. Then we got dy and dx right here. Of course, if we plug in the values, we see that the x maximum is 4 and the minimum is -4. While for y, it is the max 4 and the min is 0. 3x squared y to the 5th will be the function, so we can fill in that part. Then, of course, dy and dx after. What would make it easier, though, is if you factor out the 3, because the 3 would remain constant no matter what it's integrated by. So we start the 3 right here, 4 and -4, 4 and 0 right here, and then we got x squared y to the 5th dy dx. Of course, the next step after that, we would actually need to find the antiderivative of x squared y to the 5th. To do that, though, let's start at x squared y to the 5th dy. So in this case, the x would remain constant, so we leave that part, but y to the 5th, the antiderivative would be 1/6 y to the 6th. I'm assuming you guys already knew that. Equaling 1/6 x squared y to the 6th. So we can fill in that part right here. 1/6 x squared y to the 6th. With the boundaries being 4 and 0 for now. Then you got the dx at the end, because we still have to integrate that. So anyways, let's factor out the 1/6, which would be 3 times 1/6 will be 1/2. So then we just have to integrate x squared y to the 6th with these boundaries right here. Okay, so the next step after that, I guess we can draw. Anyways, we have 1/2, 4 and -4. And if we plug in, we have to plug in these values first, the top one, then the bottom one. So the first one we would get x squared times 4 to the 6th. And the next one we would get x squared 0 to the 6th, which I guess you guys can all figure out that means 0. So anyways, if you do the math, then you'll see that would be 4,096 x squared, then dx. And of course you factor out the 4,096 now, because that would only make life easier. So we got 2,048 right here. 4 -4. Then just the antiderivative of x squared, which is pretty simple. I think we all know that it is 1/3 x to the 3rd. With the boundaries being 4 and -4. Anyways, let's factor out the 1/3, and we would have 2,048 thirds, and then x cubed with the boundaries right there. Of course, to figure that out, course, we have our constant right here, and 4 to the third, and then we do minus the lower one, so minus negative 4 cubed. We end up with 64 minus 64. A minus and a minus would be a positive. That being said, we have the constant right there. And for our integral, we have 2048 times 128 divided by 3. Now that's actually not it. We're not going to simplify yet either because we don't really need to yet. Now the only part we have to do after that is we have to find the area in this case, which would be 4 by 8, because if you look at the dimensions of x, the highest one being 4, the lowest one being negative 4, and we have 8. For y, we would do 4 minus 0, of course. And then for 8 times 4, that we all know that that is 32. So, and we would actually divide by that. We wouldn't multiply. So that would actually become 2048 times 128 divided by 3 times 32. And eventually, if you simplify that, you will get 8,192 divided by 3. And that would be your average right there. Alright, good luck to everyone on the final exam. And have a good night.